some calculations. These numbers are preset, usually, and both the server and the client would know these numbers. And then we've got A, which is this calculation of that expression. In any case, I took these directly from the paper, and you can go and look at the paper and how they calculated them. But in all of these schemes, generally speaking, you've got some seed values that are going to allow you to do the computation that have some relationship to each other and tend to prevent the generation of zeros in the computation, is what they're doing. So they're picking these things so that you don't get zero divides in the computation. So the first thing is to take that alpha exponentiated to the q minus a and then take it modulo p. The modulo value there prevents things from getting much larger. And the calculations on line 45 to 48 basically implement that expression with the big number package in Go. So when I get done with this, I've got V, which is the verifier. And the verifier is the number that you save on the server side to be able to validate that this is this user. And pretty much that's all you save, is for a particular user, you have a verifier number. When I do this with SRP6A, the verifiers run between 100 and 140 digits decimal. So that's for a 2K prime. And I haven't seen them go out of that kind of size range, but that's a big number. You don't put that into your hand calculator, let's put it that way. So then we turn around and we save this in the database with Alice. Basically create on line 56 Alice's verification code that gets saved in the database. And other than these things that we have to have like Q, alpha, and A, we don't have to have any values that we save. We're done with the registration process, so we send back a message that's a status of success that Alice is registered. In the entire life cycle, you've got to have other things like recovery of how you reset a password or verification via email. But in our little example here, we'll just say, you're registered. There's no email checking. There's nothing. So a real system's got to have extra machinery working around it. This one doesn't. Now, this is the piece that we have. These guys are always known on both sides. So we've just made those available to everywhere. But we're going to come back to the client Alice. Now, on the client side, we also have Alice knowing whatever that P value is, the password. If you change that value, then you don't get logged in. But hopefully Alice, when they get prompted, puts in that value. And these names, Alice and Bob, are pretty common for most of these things. If you look through the literature on authentication or cryptography, you're going to see these Alice and Bob and Steve. And they give them names, but Alice is the client, and in this case, Bob is the server. So, when Alice is ready to log in, the same password as before, the P value, Alice chooses an R. And you'll notice that I have commented out a fixed R of 543. And that's my constant that I would put in when I'm going to test something like this. I figure out some kind of a constant that's in the range, and I fix the random values. That way you can run the test over and over and see that it works. In this case, for us, we're going to generate a random number in the range of 0 to 999, so a little bit less than 1,000, so these are small numbers. A real random number generation for this kind of a calculation is something like 12 to 15 digits. So you generate a much bigger random number. And I print out the random number, and then I do this calculation of x. X is alpha raised to the R mod P. So what I'm going to do on the server is, what Alice is going to do is she's going to generate a random number, and she's going to send that with her login to the server. So the message sent to the server is the username, Alice, and this X value. X is basically a calculation okay, that's been done, but it's based on this random value. So by it being based on the random value means that somebody that's watching this go by doesn't have any information about what it is. It's just Alice passed a number to the server. And there's no way to derive from that number what the password is. You can't go back and undo this calculation and figure out, oh, well, that must be the valid password. That's kind of the key here. The server, okay, that's the response to the message. So we sent this API login and we sent along X and Alice. The server turns around and says, okay, what I want to do is I want to look up Alice and save this X value. So that's the first thing it does. It has to save that because it's going to be using it later as the check that it gets at the very end to determine whether or not 2 steps from now this is a valid login. The basic idea behind this is we're going to do a mathematical calculation in 2 different ways with 2 different pieces of data that are related, but because one can be factored into the other, okay, the client and the server can both calculate this, and the end result matches. If the end result matches, then this proves that Alice is in possession of the password without ever passing the password itself. Let's go ahead and run this once and see what it looks like and see this part of it. Okay, when I run it, okay, here's the register user with Alice and the V value. You notice that has no mathematical relationship that you can discern to the password. And the server sends back a response. Okay, we got it. Okay, we've saved that away. The random that we generated is this value, and we're going to send to the server Bob this X value that we've calculated. So we can do the API login. There's multiple stages of the login, but we have to send the username so it can look stuff up, and we send this X value. That's what gets sent. And color-wise, everything that I'm making is an API call. I've made yellow. Everything that's a response coming back from the server, I've made cyan. That's the kind of greenish blue color. So here's the response, and it says the response from this API login on the server is, okay, I got it, and here's an E value. And E is the challenge that the server generates to the client. So they're sending challenges back and forth to each other.